And this little sample here demonstrates that we'd like to start with asking the user for the file name, then essentially just create an input file stream object, which is the input stream, and we start working with it from that point on and start reading it. So complete example here, you can see that we have a little example from chapter 10.4. So here we have a structure named point, and inside this point we have a couple of variables, x and y. Apparently it's the coordinate of the point or pixel on the screen. And we have an example of our friend operator for entering the point, which we already discussed earlier in our presentations, like very similar. And we also have the output operator, which is also a friend declared over here to display the point. And here's the main program. So in the main program, we first enter the input file name, and then so this happens right here. We get it from the standard input, and then we create this input stream. So input stream is the input stream for the file named such and such, entered by the user. And we can say then if this kind of like failed to be in good state right from the opening, there could be something wrong with the file system. So we just say can't open an input file, and this will throw an exception, and in that case we will print the error message, and that should be the the general general possibility here. Otherwise, we just say, okay, we're expecting some points to be present in that file, so we create a vector of points, which is a vector of these structures, and then we use overloaded input operator right here, overloaded input operator, which would allow us to do the reading. And the reading of the file would be successful if the points are stored in this format, basically the coordinates encapsulated by or surrounded by parentheses, and that's the idea of this example. So that's what's being encapsulated within the input operator. So we can we can read these points. So a very similar idea, just basically use the input and then push back member function of this vector right here allows to populate the vector with individual values. In our case, the value is the point structure, which contains two integers, x and y, in its memory. So the vector will be the vector of these points, right? So this is again, this is how practical it is. It's just that this becomes like a boilerplate or template level that you can just do a lot of copying and pasting from here, and you'll realize it's just simply working for your needs if you need to somehow process information from a standard file. What's good about it is just also employ some basic error handling of the input with relying on exceptions, which we also have discussed earlier in our semester. So this essentially keeps building up. Of course, just looking at this example may be a little bit confusing if you're not practicing with coding on your own. But if you keep practicing with the topics that we're covering in our class, this should be manageable. It should be okay to try, just because we've tried to use vectors in the past, and now is just another time that we use these vectors. So this is how what is the look and feel for working with files, but ultimately all there is to it. If I want to open a file for reading or writing, so let me save this demo right here, just duplicate this and save it. just convert it to a function which was giving us an input string demo earlier, like this. And I'll just go back to the main function right here. And so if I want to use files, I would have to include fstream, file stream header. And then what I can do is I can say standard input file stream and ifstr. So this is my attempt to create a file object which will be opening a file. If I want to open the file, I can just provide the name of the file like this, my file.txt. And of course, location of this file on the file system. If I want to be able to find this file, I need to know where this file is. So perhaps what I can do is I can say std cout and say that I want to know my current location on file system is, and I would like to print it. So what I'm going to do is I'm going to use system call to just simply say cd command without arguments will display my location on the file system, so I'll know where to look for my file. So let's see, if I compile, before I compile it for the system call, I need to include cstdlib header file. Let me build this. Yeah, this thing, I need to change it to a void. So just keep it as a demo. Okay, so this time my current location on the file system will be shown if I run this code. And so I built it fine, so I run it. You see that it tells me that this is my current location. Apparently this is within this current setting from within running this executable file. For running this executable file within my Visual Studio project environment, it's using directory as a default directory for my program, right? So from here I can copy it, and now I can go to my file manager here and say, okay, let me just go to this location, and this is of course the project location, but I will create my file here, new text document, my file dot text. Okay, so very good. And here I can say hello, this is my file. So just to populate it with some text so it's not completely empty. And then once I have this in place, now I can go back here and say if everything is okay, right? I typically say if ifstr, right? If istr is open, so that verifies whether the file has opened successfully. Otherwise, we can report that file, and let's use the file name as a string so we don't have to repeat it, copying its copying and pasting. So we could say std string file name and store it like this. And so therefore we can just use this generic file name, and we can say that if so let's open this file, just close this, right? And we say that if the stream is open, it's fine. Otherwise we can say std c error and display that the file, let's say could not open file such and such. And here insert the file name. In directory, and once again we can try this. We just basically use system cd command to display the directory, and we can say exiting, and say return 1. Right, so returning non-zero indicates that our program really hasn't exited successfully. So for instance, I changed the name of the file. We should be able to see this message, right? So this my file2.txt does not exist, I suppose, in that folder. So I'm still missing semicolon somewhere right here. Okay, and over here. Okay. So this is my once again I have just misspelled word, so let's give it another try very quickly. So here we go, right? So we say current location is this, could not open file this, in directory which is this, and exiting. So just be aware that in addition to just using and thinking about file names, it's important that file names have their location on the file system. And these simple methods would allow you to identify easier where did this fail, because the same file name the file with the same name could exist in multiple directories. And if the directory structure is complicated or not complicated, doesn't matter. You probably need to watch out what is the current location on the file system, what is the current path that you're trying to use. So anyway, this is to be continued a bit more. We need to finish this conversation about files and dig a little bit deeper into specifics of working with files. Maybe we'll say a few words also about the C library, the library of C functions, which covers our conversation about files. So we'll just continue this next week. So this is all we can do today. Thank you very much, and I'll see everyone next week.